Hello and welcome back to yet another episode. Myself, Fazira Razak Hamza, Assistant Professor in PG Department of Computer Science, and I am here to present on the course Computer Graphics. So in the last episode, we were discussing about Bressenham's midpoint circle drawing algorithms. So today, I'm going to discuss on filling. Let's see what filling is. A standard output primitive in general graphics packages is a solid color or patterned polygon area. Other kinds of area primitives are sometimes available, but polygons are easier to process since they have linear boundaries. The task of filling primitives can be divided into two parts. The decision of which pixel to fill and easier decision of what value to fill them with. So let's see first the decision of which pixel to fill. That is to determine the overlap intervals for scan lines that cross the area, and for easier decision of what value to fill them with means this area filling is to start from a given interior position and point outward from this point until we encounter the specified boundary conditions. So the first method is generally known as the scan line approach and is used in general graphics package to fill polygons, circles, ellipses and other simple curves. And the second method, that is the fill methods starting from an interior point, are useful with more complex boundaries and in interactive painting systems. So let's first see what is scan line filling algorithms. That is scan line polygon. Scan line filling is basically filling up of polygons using horizontal lines or scan lines. So the purpose of scanline filling algorithms is to fill, that is, to color the interior pixels of a polygon given only the vertices of the figure. This algorithm works by intersecting scanline with polygon edges and fills the polygon between pairs of intersections. So let's see. For each scan line, we can say that locate the intersection of the scan line with the edges. So first we have to locate the intersection of the horizontal scan line with the edges of the polygon. Then sort the intersection points from left to right. Draw the interiors intersection points pairwise. So here I have shown a figure in the next slide. That is why I have written the pair as A, B and C, D. Let's see the figure. So this is the figure. So I have taken the interior intersection points from left to right. So in the left I have A and B as first pair and C, D as the second pair. So now this is a polygon. There is a horizontal. This is a polygon and there is a horizontal scan line there. And the blue intensified pixel shows the intersection points A, B, C, D. So this is the interior intersection pair points. So there are some special cases of polygon vertices. See, if both lines intersecting at the vertex are on the same side of the scan line, consider it as 2 points. So suppose both the lines intersecting at the vertex are on the same side of the scan line, consider it as 2 points. And if lines intersecting at the vertex are at opposite sides of the scan line, consider it as only 1 point. See, it is explained like this. See, this is the first case. This is the two lines. This is the two lines that are intersecting the scan line, which are on the opposite sides. So this is being taken as two intersecting points. And this is the second one, that is, this is being shown as the opposite lines, I mean same side on the scan line, and this is being taken as only one point that is being intersected on the scan line. So this is being taken as 2 points and this is being taken as 1 point. So this is the special case of vertices. Now we have the components of polygon fill. First component is edge bucket. So edge bucket contains an edges information. Okay, the entries of edge bucket vary according to data structure we have used. So what kind of data structure, I mean what kind of polygon we are using, according to that the edge bucket entries may vary. So here in the example we have taken 3 edge buckets, that is y max, x of y min and slope inverse. Let's see what is y max is. Y max means maximum y coordinate of edge, and x of y min means x coordinate of lowest edge point updated at every scan line while scan line filling. Then slope inverse is the inverse of slope edge. Here we never take horizontal lines as the slope edges. Then we have the next component, that is edge table. It consists of several edge list, that is holds all the edges that compose the figure. When creating edges, the vertices of the edge need to be ordered from left to right, and these edges are maintained in increasing y min order. Okay, filling is complete when all the edges are removed from the edge table. When all the edges are removed from the edge table, we come into a conclusion that we have filled the polygon. Okay, now the next component is active list. Edge table maintains the current edges being used to fill in the polygon. Okay, edges are pushed into the active list from the edge table when an edge's y min is equal to the current scan line being processed. So this is how it looks like. This is an edge table. We are having so many edge tuple. Okay, this is an edge tuple. Inside an edge tuple we have so many edge buckets which contains the edges information. Then we have the information or 3 edge buckets which we are storing, that is y max, x of y min and slope inverse are the 3 edge buckets. Okay. So we'll see what is the basic algorithm is. Say assume scan line start from left and is outside the polygon. Okay, the scan line is starting from the left and it is outside the polygon. So when intersect an edge of polygon, start to color each pixel. So suppose when the edge is intersecting the polygon, we will start to color each pixel because now we are inside the polygon. Okay, when intersection happens, we are inside the polygon, right? So when intersect another edge, stop coloring. That means will be outside the polygon, so we cannot color that. So odd number of edges is inside and even number of edges is outside. The figure depicts the same. See here the scan line, when it comes when it intersects here, we will start filling. When it intersects here, we will stop filling, that is it is outside the polygon. Likewise, each scan line can fill the polygon line by line. So this is how it comes like. Okay, here it is odd number and here it is even number. Okay. Then we will see the algorithm. Algorithm is like, first step is we will process the polygon edge by edge and store in the edge table. Or we will process the polygon edge by edge and each edges are stored in the edge table. Storing is done by storing the edge in the same scan line edge tuple as the lowermost point's y coordinate value of the edge. Okay, that is the y max. So storing is done by storing the edge in the same scan line edge tuple. Okay. Here we take the edge in the y position. Then we have, after addition of any edge in an edge tuple, the tuple is sorted using insertion sort. Okay, according to its x of y min value, that is the lowest x coordinate value. Okay, after insertion sort, the whole polygon is added to the edge table and the figure is now filled, right? Because after the complete polygon is being scanned or being scan lined with a horizontal line, all the whole polygon will be filled with a color. Okay, the next step is filling is started from the first scan line at the bottom and continued till the top. That is, the scan line will be scanning the polygon from the bottom side and it continues till it reaches the top position of the polygon. Now, the active edge table is taken and the following things are repeated for each scan line. The active list is now taken and we are repeating the same thing. What is we repeating? First step to repeat is copy all edge buckets of the designated scan line to the active edge tuple. We're copying all the edge buckets into an active edge tuple. Perform an insertion sort according to the x of y min value, that is the lowest x coordinate values are being taken and performing an insertion sort. Remove all edge buckets whose y max is equal or greater than the scan line. So, when the y maximum of the y coordinate edge is equal to or greater than the scan line, we are removing all the edge buckets. Why? Because y max means we have finished filling the polygon. Our next step is fill up pairs of edges in active tuple. Okay, we are filling up the pairs of edges in active tuple. If any vertex is got, follow these instructions. So for vertices, we have another instruction, that is, if both lines intersecting at the vertex are on the same side of the scan line, consider it as 2 points. Okay. If it is on the same side of the scan line, we are considering it as the 2 points. And if the line intersecting at the vertex are at opposite sides of the scan line, consider it as only 1 point. Okay. So when intersecting, we are considering it as only 1 point. If it is not intersecting or if it is on the same side of the scan line, we are considering it as 2 points. Then update x of y min, that is the lowest x coordinate value, by adding slope inverse for each bucket. Slope inverse means the edge slope. Okay. Thank you. Thank you for listening.